Good morning, everybody. We are going to do some nutshell notes on solving systems of equations algebraically using the substitution method and the elimination method in this video. Should have learned in class how to do these things, and we're just kind of recapping here. So, general form, one equation is written as y equals mx plus b. Or you might sometimes see that one equation has been written as x equals something, where everything else is over here. There really isn't a general form for that, but I've kind of created my own down here to show you that you have the x by itself, and then you have a y term and a constant without a variable, usually, over on the other side. Or option C is that one equation can easily be converted into one of these formats. So you might want to have to rearrange into here, or you might have to rearrange into an x equals. Okay, so process. If necessary, we're going to convert one of the equations into a format described above, that y equals or x equals something. Then we're going to substitute this into the other equation. Remember, substitution is just plug in or replace. Like a substitute teacher replaces your regular teacher for the day. So once we do that, we're going to solve for the variable that is still left over. Sometimes that might be x, sometimes that might be y, it depends on your setup. Then lastly, you're going to plug that value back in and solve for the remaining variable. Now, if you solved for x here, you would then plug back in to solve for y, or you might have to plug back in to solve for x if y was your original. Okay, so in this example right here, we have a relatively easy example. We already have y by itself, and it's equal to x plus 7. So no rearranging necessary here, but just know that sometimes you're going to have to do that. So we're going to then take this equation, 2x plus 3, and where this y is, right here, we're going to plug in. So we're going to have a 2x plus 3 and an equals 31, and then we're going to plug in for the other piece. So leave space, equals 31, and my x plus 7 gets plugged in right there. Now we just go through our normal solving steps. So distribute 2x plus 3x plus 21 equals 31. And then we have combine like terms, 5x plus 21 equals 31. And then we might subtract 5x equals 10, which means that x is going to equal 2. So what I usually like to do, since a system of equations has to have really two answers, is I do a blank comma blank up here, and that x that we just got is going to go in the x spot. So now, as far as plugging in goes, I can plug this in for x right here, or I can plug it in for x right here. Since we are finding the point where these cross, it doesn't really matter. So I'm going to choose the easier one, which looks like this one is the easiest. No, that was really botched. Sorry about that. So I'm going to take that equation. I have a y equals, and then I'm going to fill in for that x, and then plus 7. So that x is going to be a 2. And then quite easily I can go y equals 9. the reason that I like this easy one is because I could actually do all of this in my head. I just wrote it down for the purposes of the note sheet. So that's a y value of 9. So if I were to graph both of these equations, they would cross at the point 2, 9. Okay, elimination method. So moving on here. Both equations are written in standard form. So ax plus by equals c. And such that one variable will be eliminated. Let's see, that didn't write very well. Eliminated. When added together. Or sometimes one or both equations can easily be converted into this ax plus by equals c, where one variable will cancel. So process, if necessary, convert one or both equations into that standard form. And then here, the cool thing about this one is that we get to add or subtract the equations to eliminate a variable. I usually prefer to add them because it's easy to see a plus and minus that will cancel, but you can subtract if you have two positives with the same coefficient. Solve for the variable that's left over after you've done the addition and cancellation. And then we plug back in to solve for the remaining variable. So here's example number 1. This one has a set of variables that are automatically going to cancel. Notice that the p's are lined up right here. The q's are lined up right here, and my numbers are lined up right here. So these p's are going to cancel right here because -2, when I add, cancels with +2. And so then right here I get 4q equals, and then -2 plus 22 is +20. So then I can easily divide here. So divide by 4, q equals 5. Now since q is kind of in the y spot, I'm going to put it in the y location of my xy coordinate over here. So now what I need to do is plug in and solve for the x. And the second equation has all positive variables, so I'm thinking that this is going to be the easiest one. So let's start with my 2p plus 3. Now I'm going to plug in for the q equals 22. And let's plug in a 5 right there. Now just some quick solving. So 15, 2p. Those 2's just don't seem to want to write for me today. And minus 15. So 2p equals, let's see, what is that? 7. And then I'm going to divide by 2. And I get p equals 7/2. If your teacher's okay with fractions and decimals, this would also be 3.5. So that's going to be right here, my 7/2. So this is an additional example that I added after looking through this. So you're going to need to pause the video right now and copy this down. Elimination example number 2. So sometimes, and by sometimes I actually mean quite often, you need to modify an equation in order to create the elimination effect. So if you look here, if I look at my x's, the 2x is not going to cancel with the 3x. The negative y is not going to cancel with the positive 4y. So we feel like we might have to rearrange this one into this first one into y equals mx plus b and maybe use substitution. But elimination is still really simple in this one. So what I want to do is I look at a positive 4 here, and this is like a negative 1. And I can very easily convert a negative 1 into a positive, or excuse me, negative 4. So what I want to do is multiply over here by negative 4 and multiply over here times negative 4. So what I get is negative 8x. Oh, I'm sorry. We actually want to multiply by positive 4. My bad. So multiply by positive 4 over here and 4 here. So we would get 8x minus 4y equals negative 36. And then I keep this bottom one exactly the same. 3x plus 4y equals negative 14. So now what I see is that my 4's here will cancel because I have that positive and negative effect. So I'm going to add them. It cancels. Here I'm going to get 11x equals, and then when I add over here, let's see, 6 and 4 is 10, and this is going to be 3, 4, 50. Now, so I just realized I made another mistake. Sorry, guys. So this, I was still multiplying by a negative on one of those. So that 36 is actually going to be positive. And how I knew is because I knew that this was supposed to work out to be a nice answer, and it wasn't going to be. So now let's try that addition again. So I did add 8 and 3 together correctly. So then 36 combined or added with negative 14 is like subtracting. So I'm going to get a 22. And that works out a whole lot nicer than what I was going to get. So divide by 11, and I get x equals 2. So I'm going to have a 2 up here in my x comma y. And now I just need to plug back in. So I can plug back in for anything that looks like the easiest. So I can plug back in, let's see, what color do I want to use here? I can plug in for this x right here, I can plug in for this x right here, or I can even plug in for this x right here if I want to, since it's just a modified version of the other one. I'm kind of thinking that one of the first two equations is going to be the easiest. Let's just go with the first one since it takes up the least amount of space. So 2, I'm going to plug in an x, and then minus y equals 9. And if you're not comfortable with negatives, that one might be your not favorite choice because we have that negative y that students tend to lose that negative. So here we have 4 minus y equals 9. And then we can minus the 4 over. And this is where students tend to go, oh, the answer is 5. But we actually have negative y equals 5. So we have to then go back and divide out that negative. Divide out the negative. And I get y equals negative 5. So negative 5 is there. Answer's done. Sorry for all of the mistakes that we made today, but hopefully you learned from this video, and email me if you have any questions.